Hello, it's Joe here from the Ffiws Makerspace. Hope you're all keeping well. I'm really missing our maker sessions in the Ffiws Makerspaces, and hope you're all keeping safe and well. And I hope that when it's safe to do so, and the Ffiws Makerspaces can begin to reopen, however that will work, I really look forward to seeing you all there again in the future. So they've asked me to put together this little video of getting started with FreeCAD, which is one of the CAD packages, and the one that I particularly use to make 3D models that can be used on some of the machines in the Ffiws Makerspace. There are other ones, Fusion 360 for example. I'm a big fan of free and open source software, which FreeCAD is. That means that at no point do any of the features of the software will you have to pay for them, even the really complex stuff that it can do that we're not going to talk about in this video. They're never going to start charging you for it, which some of the other packages do. Also, it works across all the platforms of computing, so it works on Windows, on Linux, and on Apple laptops, so anybody with any of those operating systems can use it. And the other thing that was of particular interest to, well, one user in particular in Porthmadog, but a few users that I know of kind of elsewhere, is that it isn't cloud-based, so it doesn't need to store much information about your designs online, and it doesn't need an internet connection, which is useful. For example, one member at the Ffiws Makerspace in Porthmadog used to travel in by train, and he was like, well, if I learn... In his case, if I learn Fusion 360, I can't use it continuously on the train without an internet connection. So FreeCAD was a good choice there. So the first things to do, and I'm going to presume that people have done nothing with CAD before, so don't get put off when you see all this complicated stuff, most of which we're not going to look at. I'm just going to do a little bit to hopefully get you started and able to draw a few kind of simple things up in FreeCAD. So the first thing to do, if you want to do this, is Google FreeCAD and find the website and find the download page and download and install the version for your type of computer operating system, and then start it. When you start it, you'll see this screen, hopefully. You won't have any of these recent files because you won't have done anything recently if you've just installed it. You should just have this Create New. So if we click Create New, you'll see that there's a tab here called Unnamed One. You've still actually got this start pages there, but Unnamed One is your new kind of project file. Usual things like you can do in anything like in a Word document or whatever. You can go and you can file, save as, and give your project a name and stuff like that. Okay. What I'll talk about first is the interesting thing that FreeCAD does that's different to a lot of other CAD softwares is it uses this idea of not having all the tools on the screen at the same time. And the way that it does that is it uses a thing called workbenches. So if you left click on that drop down menu, you'll see that these are all the workbenches that come as part of FreeCAD. And a good way to imagine these is that if you had a massive workshop with lots of different benches in, and as you walked between these benches, one of them would have all your drills on, and one of them would have hammers, and one of them would have blah, blah, blah. And they would all have different tools on each workbench. And the tools are organised into groups of things that are hopefully useful. We're not going to look at all of these workbenches, but we are going to switch between them. The brilliant thing about these workbenches is that it automatically carries your work from one workbench to another, which obviously you would have to do physically in a real workspace. But yes, so say I'm in this Arch workbench, which is I call it Arc. It should be Arc really, because it's short for architect. Say I had an object in there, and then I switched to Part. The object will automatically be there, but the tools I can use change. We're not going to look at all of these, as I said, but yep. So there's Arc, which is useful if you're working on something architectural. It's got a heap of tools that are more useful for kind of architecture type purposes. FEM is one that I don't use very much, but it's for like finite element analysis and mechanical. I mean, you can do like some really clever physics against the objects that you create, almost like kind of scientific tests to see how they do under force and in different liquids and gases and all kinds of stuff. We're not going to do much with that today. Mesh design is one that I'll quickly look at in a little while. Mesh design is useful when you're exporting an object that you've created to, say, for example, 3D print. That's the kind of desk we'd use. We'll use part and part design a little bit. Path, we'll maybe have a very quick look at Path with a project that I've done previously. Path is the workbench we would use that sets up tool paths that, for example, in the Ffiws makerspace, the CNC router machine could follow and cut out your object. What else have we got? Ship is what I discovered the other day. We're not going to look at that, but Ship is in a whole suite of tools for designing boats, but also testing the buoyancy and how well boats perform in water, in weather conditions. I mean, yeah, a fantastic set of tools if you're into boat building. Sketcher is one we will use that allows people to draw 2D sketches, which then can be pulled and extruded and shaped into 3D objects. What else? That's probably it. Tech Draw is quite useful. Sometimes I CAD something in 3D that I need to make on manual machines in my shed, like a milling machine and a lathe and things like that. And excuse me, quite often I want to work from a technical drawing, and this has some really cool tools that just pull 3D objects into a proper technical drawing that you can print out and stick on your wall in your workshop and work off of. Okay, but for now, let's click the part workbench. Okay. The part workbench has got some really simple little tools that allow us to. You can build quite a lot just with the part workbench if you're creative enough. But you can do some cool stuff on here. And the first thing we're going to look at is these yellow tools over here, which are called primitive objects, which just basically allow you to draw primitive shapes. If you hover your mouse over them and don't move it, after a few seconds, it will show you these little lines of text that tell you a little bit about what they do. So if we click the Create Cylinder one, you can see that we've created a cylinder. Now, mine is set up that if I use the center wheel on my mouse, I can zoom in and out. There are also zoom buttons that you can use that can help you here. Interestingly, you can see that we've created this little cylinder, and it appears on this file tree here, and we'll get into how you can change the cylinder dimensionally in a moment. But I just wanted to mention the different ways that you can move this view about. So there are different navigation styles that are used in CAD packages, and if you've used a CAD package before, you might have a preferred style. If you right click and go to navigation styles, if you recognise any of these, so for example, if you've used Blender or Maya before, it might be that you're more comfortable with that setup. So click one of those, and it will navigate however that software does. I use this gesture one. It's just something I've got into, and what gesture means is that if I left click and move the mouse, it kind of rotates not the object, but it rotates the view of the object. If I right click and move the mouse, it just moves the object but doesn't change the sort of viewing angle. And if I use the center wheel or the center button, I can zoom in and out by moving up and down with the mouse. There we go. Other ways that you can interact is you can use this square here, this cube, sorry, to rotate the angle or return to a particular face. The other way is you can use these tools up here, which basically the solid blue surface is where you're looking from. So that's a few different ways you can navigate. Okay, so we've created this cylinder, and you'll notice that we can select individual parts of the cylinder. Oh, sorry, zoomed in a bit too much there. Or we can even select the edges of the cylinder. And that's because solid objects tend to be made up of a flat surface and edges. If we want to select all of it, we can come over here to this file view, a left click, and that selects everything at once. If we've single clicked that, we should have this dialog down here, in which there are some things that we can change. So the most obvious ones we'll look at are radius. So if I change the radius to 3, it gets bigger. If I change it to 34, it gets really big and we'd have to zoom out. If I put the radius at 3 and change the height to 12, it gets taller. If I make it 2, it gets shorter. Pretty intuitive stuff. The other thing people get ask a lot about this is, how do you move an object? So if you double click on the object in the file view, you end up with this set of arrows and points, and what these allow are for incremental steps of movement in the given axis. So if I grab this red x-axis arrow here and pull it along, it sort of clicks along. If you can see, compared to the grid behind it, it clicks along in 1 millimeter increments. The same if I click the z-axis and pull it up, and or down, and the same if I use the green axis, the y-axis, and pull it across. Rotational increments are, if I grab these, the little spheres, I can rotate it around a given axis, and I can change the amount. So at the moment, it's set to rotate in increments of 15 degrees, which is kind of useful because you can get 3 increments means 45 degrees, 90 degrees, etc. Are quite easy to do. But if you wanted to move something very slightly by 1 or 2 degrees, you could simply change this value and then use the spheres again. So once you've finished moving it and you've got it in position, you can OK it and it stays there. So that's kind of that. Actually, let's just move that back so it's sat on the base of the sort of reference plane. Okay, let's create another object. Let's create a cube. Okay, so we've made a cube and it's placed it sort of at the 0, 0 point. So those two things are overlapping. So obviously we could, if we didn't want them overlapping, we can select the object and we can move it out of the way. But let's say, for example, and like the cylinder, if we select the cube, we can change the length, width, height, and various other attributes of it. One of the common ways of building objects is to, for example, let's say we've got this cube and we want to cut a hole out of the centre of it. So a classic way to do that would be to make the cylinder the size of the hole that we wanted. So say we wanted it 2 millimeters by, and to go all the way through, then we could move it into the centre of the cube, roughly. Is that the centre? No, nowhere near. But you could move this into the centre of the cube, and then still on the part workbench, there's a great thing where we can say select the cube by clicking it, and then hold down the shift key and select the cylinder. And then if we come up here, these blue and white objects here are different sort of Boolean operations that we can do. So if we make a cut of 2 shapes, this should cut the cylinder out of the cube. There we go. So you can see now that we've made a cube with a hole through it. Interestingly, over here, this is now just called cut. And that's like the sort of the top hierarchy of this object is the cut that we made. If we click down on this little arrow, we can see that the cube and the cylinder are still there, but they're kind of greyed out. If you hover over the cylinder and press the space bar, it actually makes it visible again. And even though this object is cut out and not visible at the moment, it's not visible and it's a hole. We can still make changes to, say we decided actually I want that hole to be 6 millimeters, 3 millimeters radius. We could make a change to it in there, and when we click off, it will recompute the cylinder as a cut out of the object. So yeah, using that, there are also things where if I just go back to, say, I just use Control and Z there to sort of undo some of the things I did. So say we'd actually moved our cylinder and our cube to there, but we wanted these two things to actually be a union. We could click and make them a fusion of parts, and then we can select the whole thing as one object, for example. Yeah, so there's lots of things we can do with these simple Boolean operations to build up a kind of structure. There's other snazzy stuff that the part workbench does. Let's, how should we do that? Let's make a hole again using our cylinder. So let's roughly put it in the middle. Nowhere near the middle, is that? No, there we go. I never quite get that right. Ooh, there we go. That's in the middle. Select the cube first, because that's what we want to cut out of. Select the cylinder, click this, and then we've got a hole. Say, for example, we wanted to put a nice rounded edge on this edge here. We can simply select that edge, which I've just done, by hovering over it. You can see when you hover over an edge, it turns yellow, and then you click it, and it goes green. So if we select that whole edge there, for example, we could use this tool here, fillet the selected edge of a shape. We can click that tool, we get a dialog box. The selection is the selected edge that we've done, is selected already, and the radius is set to 1 millimeter. Let's just see what that returns. So if we OK that, there we go. We can see that it's applied a radius to curve that edge into there, and then that becomes a surface that we can kind of interact with as well. So yeah, there's lots we can do on this part workbench. Let's just quickly look at a different way of creating geometry though. Let's go to the sketch workbench. In fact, let's start in a new document and we've gone to the sketcher workbench. And in here we're going to click this button, which is create a new sketch. So a sketch is a two-dimensional drawing, and what we're going to do is we're going to choose which orientation we're looking at the drawing in, or which we're going to draw in. So if I draw here, this is going to be a flat object. If you imagine that this cube is like the 3D printer, and we're looking straight down onto the bed, you'd be drawing like a 2D object straight onto the bed of the 3D printer. Please don't draw on our Ffiws 3D printers, that would be very bad. So let's select that as the view that we're going to draw in. And you can see that this workbench has lots of different tools. These tools here that all have a white line with red dots are all the sort of drawing tools. So there are tools to draw single straight lines, to create arcs, to create circles, to create sort of collections of lines, to create rectangles and squares, polygons and stuff. Select the multiple point polygon tool, and say we wanted to draw a part that's like a sort of trapezoid part, and you don't have to be accurate at this stage, but say that that's our part. Oh, just before I finish, so I want to finish this part by making the last line go from this point here over to this point, and the way that I can make them join is by left clicking to draw the line, but then left clicking to finish the line on when that point is yellow. So I left click there, and then we've got kind of our object. If I right click, it returns the cursor to a cursor rather than the tool. Okay, so this is our kind of sketch, and that indeed is a sketch. Notice this thing we're going to look at in a minute is it says under constrained sketch with 6 degrees of freedom. Constraints are basically things that tell the computer how long things are, what position in space they're in, where they are relative to other objects and stuff like that. And they can be really, really, really useful in CAD design, but they're also kind of not necessary all the time. So if we just close this, we end up with this sketch back in this view, and it's not a constrained sketch, so it appears as a white line. If it was a constrained sketch, it would appear as a green line. But we can do lots of things just with that kind of sketch as it is. So if we go back to, for example, the part workbench, with this sketch selected here, we could click this tool, which is extrude a selected sketch, and we can extrude it 10 millimeters, and just leave this as a long normal. You can experiment with custom directions on your own maybe, but if you click that, you end up with the sketch is now underneath an object that's called extrude, and it's a 10 millimeter extrusion of that sketch that we just made. So that's a quick way of making an object. But it's a less useful way than a fully constrained sketch. And if we go through it, it'll become apparent why at the end. Okay, so I've just kind of undone the extrude and I've double clicked to go back into the sketch to edit the sketch. So the first thing I'd like to do is I'd like to basically the name of the game is to get this 6 degrees to disappear to 0 so that it's fully constrained. So one of the things I'm going to do to constrain it is actually it's detected that when I've drawn this line that I probably want that line to be horizontal. So it's given it a constraint. So if I click this one and I click this horizontal constraint, that's because I've got both lines selected. If I just select this line, which isn't horizontal, and click that horizontal line, it gives it that constraint, and it makes it a horizontal line. Now, if I click and move this, it can still move in lots of things, but it can't ever not be horizontal. Okay, so there we go. So that's brought the degrees of freedom down. We can do things like so let's say click this center point and this top line. We could set a constraint that's a vertical, not between the line, between this point, one of these points on this line, and this point here. Let's set a vertical distance to set the distance between these two lines. So at the moment it's 47.18, so let's put it at 45 millimeters. So that's added this dimension here. So again, now I can move this sketch, but I can't change that dimension by dragging it. I can if I double click on it and change the value, but I can't do it by dragging alone. Okay, say we always want this point to be across this way from this line. We could put a horizontal distance there. At the moment it's 19 millimeters. Let's make that 20 millimeters. So we can say that that distance there will always be 20 millimeters. So now it's getting more fixed. We can only move this edge. So let's say we want this point to always be across from this line 30 millimeters or 40 millimeters. There we go. So now that line's fully constrained. We can't do anything with that. We've still got 2 degrees of freedom. So quite often what happens is you start to not be able to work out where your degrees of freedom are. So the best thing to do is to click and drag your sketch and try and see where things are. So it looks like if we make these points have a dimension from this line or this point, from this point to point, from this point to this point, if we make it have a horizontal dimension of 35, and we make this one have whatever it is. I've selected the line as well. I don't want the line, I just want the point. Select that point and that point. Set the horizontal distance. Let's leave that as it is. Okay. Ooh, can't click OK. There we go. You can see now that the sketch has gone green, and it's a fully constrained sketch. Now, it's not immediately apparent why that's useful, but say we want a hole in this object when we can extrude it. So we draw using the circle tool. You can click a center point and then click here. Now we need to constrain. We'll right click to remove the tool, select the circle, and we want to constrain the arc radius. So let's say its radius, we always want it to be 8, so a 16 millimeter wide circle in terms of diameter. Say we always, no matter what we do to change this end of this object, let's say the design means that we always want this center point of this to be, let's say, 30 millimeters horizontally from that point, and 17 millimeters vertically up from that point. So that's where constraining can get really useful, because it might be that we change this dimension here and change this edge of the object completely, but it hasn't skewed the object and it hasn't moved our hole, because that's constrained to other points of the object. Hope that makes sense. So a fully constrained object, we can still do exactly the same. We've got this constrained object, and we can extrude it. Extrude it 10 millimeters again, and you can see that it's left that hole in there. And we can still do all these other things that we can do in the tool workbench. We can apply fillets to edges and all that kind of stuff. So there we go. There's enough perhaps there for you to get going with. Let's just have a very quick look at what we could do with our design. So for example, if we went to the mesh design workbench, we can do a file export, and you have to select the object to export. So we want to select all this object, do a file export, give it a name, and it will save it as an STL mesh, which is exactly the type of file that we would use in the slicer software. So you could take that STL file, load it in the Prusa slicer or the Cura slicer that we have on the machines in the Ffiws makerspace, and then put it on the SD card and print that object on the 3D printer. What else are we going to look at? Oh yeah, just quickly, you could go to the path. Actually, let's not look at this in the path workbench. Let's just get rid of that. Let's open one that I did previously. So this is an object that I modelled in FreeCAD. I actually only modelled the central disc here, and these green lines and this cylinder here are representative of the tool and the tool path that this tool would take in the CNC router in the Ffiws makerspace to cut this object out of a flat piece of whatever, plywood I think in this case. So yeah, so it's a bit complicated, but I'll share a link, because I wrote a tutorial for Hackspace magazine, which you can get for free. You can download, and you can read my 2-part tutorial in there about how you set up tool paths for the CNC machine to be able to cut objects that you've modelled in FreeCAD. But yeah, so for example, FreeCAD, just to show some of the power of it, it shows you how you can set up tool paths, and you can also set it up to kind of emulate the tool and show how it actually goes through the job and cuts the various things that you've designed and laid out tool paths for. So yeah, it's a really, really powerful bit of software. I hope that's given you enough confidence to have a little go and get started. And as I said at the beginning, really, really look forward to seeing you back in the Ffiws makerspace when it's safe to do so. Everybody take care, and ta-ta for now.